In this video, I'm going to tell you the ABC of ECG, or shall I say the PQRS and T of ECG? Now, if you think you already know this, can you try to name this waveform? In the next few minutes, I'm going to tell you the very basics of ECG and its nomenclature. Let's start from the ECG graph paper. ECG graph paper is divided into tiny squares whose each side measure 1 millimeter. This paper usually moves at the speed of 25 millimeters per second. That's why horizontally, each small square represents 0.04 seconds and each 5 units, that is one large square, represents 0.2 seconds. Now let's see what this vertical line represents. Vertically, the ECG graph paper measures the voltage or amplitude. Usually the ECG machine is standardized so that 1 millivolt signal produces a deflection of 10 millimeter amplitude. So simply put, it means that 1 millimeter vertically is equal to 0.1 millivolt. Remember, these standardizations or calibrations and speed can be changed, and hence we should look at these parameters before starting to read the ECG. As you might know, ECG basically records the electrical activity of atria and ventricles. It records depolarization, which is spread of stimulus through the heart muscle, and repolarization, which is return of the stimulated heart muscle to its resting state. The P wave represents atrial depolarization, QRS wave represents ventricular depolarization, while ST segment, T wave, and U wave represents ventricular repolarization, that is return of the stimulated ventricular muscle to its resting state. Now you might wonder why we don't have any representation in ECG for atrial repolarization. Well, because normally atrial repolarization has very low amplitudes and hence it does not get recorded. Now let us see what is a PR interval. PR interval represents the time it takes for the stimulus to spread through atria and pass through the AV junction. It is measured from the beginning of P wave to the beginning of QRS complex. Since PR interval may slightly vary in different leads, you should note the shortest PR interval for interpretation. In adults, normal PR interval is between 0.12 seconds to 0.2 seconds, that is 3 to 5 small squares. Now look at this complex. This is called QRS complex. The nomenclature here might appear confusing, but it is actually very easy. Remember, the first positive deflection in the QRS complex is called R wave. The first negative deflection before the R wave is the Q wave, while the negative deflection after the R wave is called S wave. The capital letters of either Q, R, or S are used to denote waves of relatively larger amplitudes, and smaller letters are reserved for smaller waves. Now, what if there is only one wave which is positive? Obviously, as per our definition, we'll call it R wave. Now, another interesting point is that the negative deflection should cross the baseline for it to qualify as either Q or S wave. So, in this waveform, this negative deflection cannot be categorized as S wave. Imagine a situation when there is only single negative deflection. Well, since there is no R wave for comparison, hence it is called as QS wave. Another thumb rule to know is that interval term in ECG is used to denote time between two specific ECG events. It includes at least one wave and at least one segment. It basically represents the duration, while segment is the distance between two waveforms, and it usually is isoelectric in a normal ECG. So this distance starting from the Q wave to the end of S wave is also called as QRS interval or width. Usually it measures around 0.1 seconds and it represents the time required for stimulus to spread through the ventricles. Look at this portion of the ECG from the end of QRS complex to the beginning of T wave. This is called as ST segment, and the junction between the end of QRS and beginning of ST segment is called J point. Now come to this T wave. It represents ventricular repolarization. A normal T wave has an asymmetric shape. Its peak is closer to the end than its beginning. This insignificant looking like detail becomes important especially in conditions like myocardial infarction and hyperkalemia when the T wave becomes symmetric. Now coming to the second last important measurement. This is QT interval. It's measured from the beginning of QRS to the end of T wave. So technically it includes two waveforms, the QRS complex and the T wave. The normal value of QT interval depends on the heart rate. It's basically inversely proportional to the heart rate. Now, to overcome this issue, people have come up with certain formulas to calculate the corrected QT interval, which is called as QTC. Two of the commonly used formulas are Bazett's formula, where the corrected QT, that is QTC, is equal to QT duration divided by the square root of RR interval. The second one is the Hawkes formula, where QTC is equal to QT plus 1.75 times the heart rate minus 60. Normally, QTC is between 0.33 seconds to 0.44 seconds. I won't discuss its prolongation over here, but it will be discussed in a later video. Now, coming to the last deflection that is sometimes seen after the T wave, it is called a U wave. Its exact significance is unknown, but it's understood that it represents the last phase of ventricular repolarization. Normally, the direction of U wave is same as the direction of T wave. So now that you're well acquainted with all these waves, can you identify this? I hope this was helpful. Thank you.